spent a good part of last week thinking about how to combine bullet RBD simulations and Vellum, and apart from a very brute force way, which we'll maybe cover in a future tutorial, I did not come up with something that satisfied me. So I was thinking, could I build rigid bodies or an approximation of rigid bodies in Vellum? And this is my approach. So let's first quote-unquote model that pill shape by dropping down a sphere, setting this to polygonal mesh, dialing back its scale, and increasing the rows and columns like this. Then I just want to drop down a group node, group the points by their position. So I want to put anything that's above the 0 ground plane into one group like this, and then move that up using a transform, limited only to this group. Translate it up 2.4 units like this, and then subdivide this area here. And I'm not sure if this is the proper way or the most straightforward way of doing this. It just worked for me. Again, I'm not a modeling person, so forgive me for doing this. Dropping down a Voronoi split, a line, setting the length to 2.4 and 10 points, just wiring that in here, and now I've got my subdivided pill shape here. Now I'll just gonna fuse this, and again transform this down so it sits on the 0 axis. So minus 1.3, that should center it. Well, almost. Minus 1.2. For later, for rendering, I want to group a few of those primitives into another group just for shading, so I can have a transparent and a non-transparent part of this pill. I'm going to drop down a group again, this time using the keep in bounding region with my bounding box set to be 3x3x3, highlighting this and moving it up. So I only select the upper part of that pill shape here, and let's call this one transparent. Again, that's only for rendering for later. For the simulation, it's irrelevant. Now let's prepare the simulation, and when I run a simulation, any shape that is exactly symmetrical will behave weirdly, because what it could do is balance out on this end here, because it's perfectly symmetrical. So let's just fix this with another transform. We just slant this, or angle this pill a bit, like this. Now finally what I want to do is another group. Call this one pill, so we can separate it from the grains inside later. And I just want to put anything in this stream into this group, like this. Now, let's configure our quote-unquote rigid body. Which I'm going to do, of course, by dropping down a Vellum, configure soft body. Because in my naive thinking, a rigid body is just a really stiff soft body. So let's just set that up by scrolling down here and setting our bench stiffness to a really high value, such as the stretch stiffness, so 1e plus 10, that means a 1 with 10 zeros, and also decrease the damping value to the same value as a stretch. Next, let's drop down a null, so we can visualize the constraints that we're generating here after the Vellum struts. So let's zoom in a bit, and you can see those individual struts connecting opposing points here. So let's dial this in a bit and make it a bit more firmer, a bit stiffer. So let's increase the direction jitter, so not only perfectly opposing points will connect it, but they will have a bit of a spread. Also increase the constraints per point, so we are building more connections per point, and increase the stretch stiffness. And that's about it. We want to build another branch of our setup which generates the grains. So what we're going to do is take this geometry here, put down another transform, wire this in here, and let's just ghost this and have this one highlighted. And we want to scale this down a bit, so the grains are inside of our capsule and not penetrating the outer walls. So let's scale that to 0.975. Just a tiny bit smaller like this. And then let's drop down a Vellum configure grain. Wire this in here and check create points from volume. Increase our grain size to 0.15 and decrease the mass a bit to 0.03. And let's highlight this one here. We can see now we have a very regular grid of grains. So let's just check jitter, and now we have a bit of a more irregular distribution of our grains. Now what we want to do, we want to simulate both the grains and the cloth in the same Vellum solver. So how are we going to do that? Simply by merging their geometries and their constraints. So drop down 2 merge nodes, like this, using one to merge the geo streams and one to merge the constraint streams, which then are going to be fed into our Vellum solver, geo, and the constraints like this. And within our Vellum solver, I'd like to increase our substeps, which is important if we have grains. They only work properly with a substep setting of about 4, 5, or upwards. However, I can dial back the constraint iterations to, in our case, 10. And I want to have a ground plane enabled. Let's just zoom out here a bit, and it's -1, -2. Well, let's set it to -3. Highlight this. Let's get back into our perspective here. And in order to be able to keep apart our grains and our pill shape, let's drop down 2 blast nodes here. wire in the geostream, highlight the blast node, and blast the pill on the one side, so we get the grains only. Copy this, and check delete non-selected, so this one will be our pill shape. Attach a few nulls here, call this one out underscore pill, wire this in here. Second null, this one's called out underscore grains, goes in here. Let's just visualize the grains, save this, and simulate it. So this might look a bit irritating because of this ghosted shape of our pill, which is just highlighted from upstream here. So when we instead highlight our simulated pill geometry, we can see both follow the simulation perfectly. So let's reset this, check real-time toggle, and play again. So that just works as expected. Well, that's our basic setup. So again, by just dialing up the settings on our vellum cloth and our vellum struts, in the basic soft body setup, we can tweak this to behave very much like a rigid body object, which then in turn can interact with our grains. So how do we go about simulating a bunch of pills here? Well, let's reset this, save again, and basically what we want to do, this is where we generate the geometry, the standard pill shape here. And this is where we scale it down a bit in order to generate the grains. So basically what we could do is just copy this pill shape and then feed it into our vellum configure nodes. Let's just do that by using our standard copy to points workflow, just creating a sphere or some other volume that defines the area where the pill should be scattered into. Let's increase our sphere's radius along the y-axis and the overall uniform scale, and let's move it up. Set the primitive type to polygon, like this, and then attach an ISO offset to turn this into a cheap and quick volume, where we then will scatter points into. And we're going to use those points and the point's position and a few attributes to copy those pills onto those points. Let's force a total count of 22 points. So we'll simulate 22 pills. I dialed in a global seed of 2 that worked for me and had 25 relax iterations. Next, in order to orient the pills a bit randomly, let's just randomize the normal vector, which is the most basic way of orienting copies. So I'll drop down an attribute randomize, set the attribute name to n for normal, set the distribution to direction or orientation in 3 dimensions, wire this in here, highlight it, and maybe enable the normal display so the normals point in different directions here. Perfect. Now let's drop down a copy to point sub, and let's first use the geometry used for the grains, wire those in here, highlight it, and let's uncheck the normals here again. We can see that looks decent apart from these normal errors, which should be used for orientation but not for shading. So let's exclude the normal attribute transfer by just adding hat normal here. So now we have everything except the normal transfer. Let's just copy this and wire in our standard pill here, which we're going to use for simulation. So those go into the vellum cloth and the vellum configure grains respectively. So let's just check. Yeah, both on the same position here. And if we highlight the grains are instanced into those copies here. Perfect. So again, let's highlight the out grains and ghost the out pill shape here. And let's run our simulation. So, as you can see, everything is behaving as expected. When we zoom in, we have those pills with the grains inside of them, colliding with them, and moving around. So now what I have to do in order to render this using Redshift is create another geo, obj merge the grains in there, then shade the out pills using the groups transparent and non-transparent. And maybe what I'd like to do here is extrude the pill a bit to give it a bit of thickness in order for realistic rendering. So that's my attempt on simulating rigid bodies using vellum only, and I think I'll be talking about combining RPD simulations with vellum in a future video. So until then, have fun, intrigued what you guys build with this, and it's cheers and goodbye.